Welcome to AC BTech, your guide for BTech and beyond. In the today's topic, we will discuss regarding the Zener Diode. Okay students, what is the major application of a Zener Diode? Zener Diode can act as a voltage regulator. Now what is the basic difference between a ordinary PN junction diode and a Zener diode? Okay, here the conductivity of semiconductor increases depending upon the doping concentration. In the first lecture we clearly studied what is a doping. Adding of impurity is called a doping. Is it clear? Now what is the ratio of adding? That is a doping level of concentration. That we will discuss now. Okay students, today's our topic is Zener diode. Zener diode first. Now generally diodes are classified depending upon doping concentration. Depending upon doping concentration. Doping concentration. Suppose if you take an ordinary diode, first you can take ordinary diode. This ordinary diode we will call as a PN junction diode. Then it is 1 part in 10 power 8 to 11. This 1 is nothing but impurity. Okay students, 1 impurity in this ratio. Then it is ordinary diode, it is we will call as a lightly doped. Lightly doped. Now second, moderate. That moderate PN junction diode, that is 1 impurity in 10 power 6 to 8. 1 impurity atom 10 power 6 to 8. This we will call as a medium doped. Medium doped. This PN junction can be represented as a Zener diode. Next, highly. This PN junction, this known as 1 impurity in 10 power 3. 1 impurity in 10 power 3. This is heavily doped. Heavily doped diode. This diode we will call as a tunnel diode. Tunnel diode. Like that, depending upon the doping concentrations, depending upon this doping concentrations, this PN junction diodes are changed from PN to Zener changed, from PN to tunnel changed depending upon the doping concentration. Okay students, now basic exam, Zener diode. Zener diode, a ordinary diode which is heavily doped under reverse bias condition. Under reverse bias condition. Okay, a ordinary diode which is heavily doped under reverse bias condition. Next, Zener diode is also known as reverse bias diode. Reverse bias diode. Zener diode is also known as reverse bias diode. Another name, Zener diode is also known as breakdown diode. Breakdown diode. Zener diode is also known as breakdown diode. Okay, depending upon breakdown voltage, this Zener diode is classified two types. Depending upon breakdown voltage, the Zener diode is classified into two types. Now what is breakdown? We will see. Generally breakdown occurs when diode is operated in reverse bias. Generally breakdown occurs when diode is operated in reverse bias. Students listen, okay? Generally breakdown occurs when the diode is operated in reverse bias only. Next, if you see the symbolic representation of Zener diode is, this is a symbol. It is a positive and negative, anode, cathode. It is a Zener diode, symbolic representation. This indicates Z. Next, breakdown of Zener diode, breakdown voltage of Zener diode lies between few volts to 100 volts. Breakdown voltage of Zener diode lies between few volts to 100 volts. Okay. If a Zener diode is heavily doped, then its breakdown voltage is very less. That is less than 6 volts. As diode is heavily doped, depletion width expansion is less or very narrow. Already this concept we have seen from the PN junction diode. The doping concentration is inversely proportional to the depletion width expansion. For a lightly doped diode, width expansion is more. For a heavily doped diode, width expansion is very less. Okay, due to less width expansion, it exhibits a strong electric field. Okay, due to less width expansion, it exhibits a strong electric field, across the depletion region junction, across the depletion region junction, that is electric field is in a order of electric field is in an order of 10 power 6 volts per centimeters. The electric field is in an order of that much. Okay, next. A Zener diode, under forward bias is similar to PN junction diode. A Zener diode under forward bias, it is similar to PN junction diode. Okay, students. Now, if you see the graph, volt ampere characteristics, okay, it is forward current, it is forward voltage, it is reverse voltage, it is reverse current. Now it is a forward bias region, it is a reverse bias region. Okay, under forward bias, this diode is similar to, under forward bias, this diode is similar to a PN junction diode. We will call this a cut-in voltage or knee voltage. Next, this voltage is known as breakdown voltage or VZ. Okay, and this current is known as IZ minimum. This region is known as breakdown region. Okay, now it is a heavily doped Zener diode. Now for an heavily doped diode, the breakdown voltage is very less than 6 volts. That is a breakdown voltage. Now you can see it is a breakdown voltage. The breakdown voltage, it means what you can observe from here, in a breakdown region, current through the diode increases or decreases, but the voltage across the diode will remain the same. From the graph you can see current through the diode increases or decreases, but the voltage across the diode which remains constant, constant. Due to this, due to this, due to this application, Zener diode is used as a voltage regulator. Voltage regulator. Current through the diode increases or decreases, but the voltage across the diode which remains constant. Due to this application, Zener diode is used as a voltage regulator. Now you can see here the voltage here from here. What is a knee current? Now from this you can represent what is a knee current. IZ minimum we will call as a knee current. Knee current. Now what you can say? From here you can say this is like a knee. You can take your hand and bend your elbow. Then you can see it is like a knee, a sharp. It means in a breakdown voltage the knee current is less. Knee current, this IZ minimum. It means very small current. This all breakdown. The current is very high. Is it clear? Knee current is a minimum current. Minimum current through the diode. Knee current is a minimum current through the diode is known as a knee current. These are characteristics of a Zener diode. Under forward bias, it is a forward bias. It is similar to PN junction diode. But under reverse bias, a sharp voltage is there. For a sharp voltage, a huge reverse current can be flow. Okay. Due to a smaller voltage, a strong electric field is existed. Due to smaller depletion region width, a huge reverse bias current can be operated. A larger power handling capacity can be done. Suppose Zener diode, you can see the major application. Zener diode is used to handle more reverse current, whereas ordinary PN junction diode is not applicable. Okay, the self damage of the diode can be takes place for an ordinary diode because its breakdown voltage increases and breakdown current increases. But in this case, voltage remains stable or a constant, but the current is increasing. That is the difference. If you see an ordinary diode, breakdown voltages you can observe across some hundreds of voltage. But whereas in the Zener diode, the breakdown voltage is at very less due to heavily doped region, due to heavily doped condition. Okay, IZ current is known as knee current. It is a minimum current through the diode. Okay students, this is about a Zener diode. Okay, next you can see this Zener diode, if doping increases, breakdown voltage decreases. Breakdown voltage decreases. If doping decreases, breakdown voltage increases. Okay students, this is about a Zener diode concept. In the next class we will see how the Zener diode can act as a regulator. Okay students, easy BTech guide for BTech and beyond. Thank you.